Problem number 36, we are asked to solve the following: 2x plus 2 to the x plus 2 raised to the negative x is equal to 5. There is actually, we could do a shortcut. So if we use the property of natural log, we could toss that x to the front. The problem is that there's a plus sign between the two exponents. So we need to use the properties of logs, or I'm sorry, well, the properties of exponents to kind of clean that up a bit. And so what we could do is we could rewrite this, and you got to pay attention because this is going to be hard. So the first thing I'm going to do to solve this is I'm going to move the 5 over to the other side, and you'll see what it'll make sense in a second. So I'm going to say 2 to the x minus 5 plus 2 to the negative x equals 0. Now the reason I did it that way is because we have to solve it. Alright? We have to solve this. This is a quadratic equation to some degree, you just don't recognize it yet. So what is it that we don't like about this?
Well, can't the x's just kind of like...
Yeah, you've got 2 to the x and then 2 to the negative x, and that's the challenge. And we want to use the natural log, and it seems like we should be able to.
Wait, with those x's, could you just times 2 to the x by 2?
Well, you're kind of on the right path. If I multiply everything by 2 to the x, right? One of the properties that we end up with, because they're the same base, and I want you to think about this. If I say 2 to the m times a to the n, what is that when I multiply those?
A to the m plus n.
You could do it that way, but what if they're the same?
There you go.
Oh, then it'd be a to the 2m.
Yeah, and so we don't normally think that way. It's not 2m, it's am squared, right? It's the whole thing squared. So when I push this through, I'm going to get 2 to the x squared. Then I'm going to get minus 5. Nope, we're going to leave it just like this. 2 to the x. And then what happens when I multiply the 2 to the x times 2 to the negative x? When I do this, 2 to the x times 2 to the negative x.
It just becomes 4.
Well, it becomes 2 to the 0, which is 1.
Wait, wouldn't it become 4 to the 0?
What?
No, 2 to the 0 is always, anything to 0 is always
Oh,
1.
but it would be 4 to the 0, wouldn't it?
No, because like
No, because of the property shortcut.
But even if it was 4 to the 0, it'd
It's
still be
1.
1.
Yeah.
They're the same base. If one was a 2 and one was a 3, it'd be, you couldn't use that property,
Oh,
right?
I see.
So think of it like this. If I say smiley face to the x times smiley face to the negative x, because they're the same smiley face bases, I get smiley face to the x minus x.
Yeah, okay.
Okay? All right. Now, what if I let u equal 2 to the x?
Then it would be u squared.
Then it'd be u squared minus 5u plus 1 equals 0. Now, how do you solve that? Well, this is written in the form a to the u squared plus b to the u plus c equals 0. So I could use the quadratic formula. What? Yep.
wait, is that the same as a to the x squared plus bx?
Yeah, but we're using u because we don't want to confuse you guys.
Why is that?
Too late?
Because we already used the x's and the exponents. But we should have picked a different percent here.
Yeah, well, we use you on calculus.
Hey.
Universe.
Okay, so what is A? Well, we know that A is equal to 1,
So stupid.
B is equal to -5, and C is equal to 1. So now if I plug this in, my U is equal to -5, which is plus 5, plus or minus the square root of -5 squared minus 4 times 1 times 1 all over 2 times 1. And let me double check that, make sure I didn't make any mistakes. It looks good so far. All right, so now that's going to be, are you guys ready for this? Put your thinking caps on. What was U?
U
It's
was
2x, 2 to the x.
So 2x is equal to 5 plus or minus the square root of 21, right? Because -5 squared is 25, minus 4 times 1 is 4. 25 minus 4 is 21, all over 2.
21.
Now what can I do to solve that?
To multiply each side by 2.
Well, what I could do, and it'll take another sheet of paper, we're almost done, guys. I gotta get x by itself. Well, the property of logs just means if I have the log that's the same base as this base, I could toss the x to the front. Okay, so now if I do like, let's say if I hit this with log base 2 of 2 to the x, oh wait, it's 2 raised to the x, right? Okay, and then I've got to do the same thing on the other side. I'm going to say log base 2 of all this other stuff, 5 plus or minus the square root of 21, all over 2. Well, what happens is that these bases cancel out and I can toss the x to the front, and so over here I'm going to be left with x, well, the log base of 2 is 1,
Wait,
right?
Why'd you do the log base of 2?
To cancel out.
To get x by itself, basically. So I skipped a step. Let me show you. So because these are the same bases, they'll cancel out, and then there's another property where I could toss. So this is really x log of base 2 of 2 is equal to all this stuff here. We may need to review some of our logs properties. And so when what is this going to equal? 1.
Oh, yeah.
Remember that property, right?
Why does it equal 1?
Well, you got to whatever. What we want to do is we want to think, what do we raise b to the y to get x?
Wait, can you move it over a little bit?
So like b to the y equals x, all right? So if I have a base of 2, what do I raise that to get to? Yeah, so I would say log base 2 of 2 is equal to 1, because if I take 2, raise it to the 1, I get 2, right? So this is actually 1 times x is just x, and then I have all this stuff. And you could leave it as this answer. If you want to go the extra step and you plug it into your calculator, you'll get 2 answers. It's going to be plus or minus 2.26. There any questions on that?
Wait, can you just think about that for a second?
Yeah.